a few more examples of the more basic types of integration by parts. The first one we have here is this 5x squared sine 3x dx. So similar to the last problem, we're going to use the formula integral of u dv equals uv minus integral of v du. And again, what we're going to try to do is we're going to try to make u equal to something that is eventually going to go away when we take its derivative, if at all possible. That doesn't mean it's always possible. Now, to start this one, notice that there's a coefficient of 5. And so we can factor that 5 on the outside of the integral sign, and we're left with our x squared sine 3x dx. At this point, it seems that when we define our variables u and dv, it seems like u would be x squared, because we know that the derivative of x squared is 2x, and dv is going to be that sine 3x dx. And let's see if I can squeeze it in here. Maybe, we'll move it over just a little bit for clarity. All right, so let's go to dv sine of 3x dx. Okay, now recall that at this point we have to find the derivative, and the derivative of x squared is going to be 2x dx. Then we have to find the antiderivative. All right, now be careful with this one. Notice that there's a sine of 3x, and we know that the antiderivative of sine is going to be negative cosine of 3x. Now, if this was a derivative, what we would do is we would just multiply that by 3. But this is an antiderivative. And so what we're going to do is we're going to divide it by 3. Technically, this is a u substitution, all right? But we're going to start getting used to the fact that anytime we have an internal function of a constant times x of a basic function, then we could divide by that coefficient. Okay, I keep trying to write this 3, and it's just not working for me too well on the screen. All right, so now if you don't believe me, what you could do is you could integrate the sine of x or sine of 3x and do a u substitution where u is equal to 3x. And eventually what you would see is that the antiderivative is going to be negative cos of 3x divided by 3. All right, so just keep that in mind every time we take an antiderivative of something that has like a 5x or a 1/5 x, or in this case, a 3x. We're going to use our formula. Our formula is going to be uv minus v du. All right, so the integral is going to be equal to, so we have our uv, all right, so we're just going to multiply these together. So that's going to be, and remember we have the 5, okay, so we're going to have 5 integrals of x squared sine of 3x dx, which is the original, is going to be equal to 5 times uv, which is going to be negative x squared cos 3x divided by 3 minus the integral of v du. So that's going to be minus a negative 2x cos 3x. And let me erase this so that way we have a little bit more room. Probably 5 a little bit big, so you could fast forward probably about 5 or 10 seconds. Save yourself a few moments. So 5 times v, which is going to be negative x squared cos 3x over 3 minus the integral of negative 2x cos 3x over 3. And there should be a dx in here. I'm going to squeeze it in. Okay. Now, if we were to, and there should be another parenthesis. Okay. Now, to clear all this up, all right, this is going to be equal to, I'm going to distribute the 5 through. I'm going to make this, and I'm going to factor out the 3. So I'm just going to do a little bit of algebra magic here. So this is going to be negative 5/3 x squared cos 3x, right? There should be a plus c up here, by the way. We have a negative times a negative, which is going to be a positive. We have a 5 times 2, which is 10, and we have a third. So we're going to have plus 10 thirds the integral of 2x, I'm sorry, just x, because we already have the 2 factored in there with the 10, cos 3x dx plus, I'm just going to call it C1 since our first constant integration. All right, so just like the previous problem, now what we have to do is we have to try to integrate this x cos 3x. It's not a basic antiderivative. If it was just cos 3x or x, then it would be fairly easy to do. And so what we have to do is we have to integrate this integral by parts again. All right, so there's no law saying that we can't use the same rule more than one time. You've probably had problems where you take the derivative of a chain within a chain. All right, so let's define u this time to be x. Let's define dv to be cos 3x dx. We know that the derivative of x is 1, and then we're going to have a dx because with respect to x. And then the antiderivative of cos is sine. But we're going to divide it by 3 because it's the antiderivative. If it were a derivative, we'd multiply by 3, but because it's the antiderivative, we divide, inverse operation, right? This first term just going to drop down, okay? So we're going to get negative 5 thirds x squared cos 3x plus, now I'm going to have the 10 thirds that I started with, all right? So that's going to get multiplied through. We're going to multiply by the UVV du. So we have u times v, which is going to be x sine 3x over 3 minus the integral of v du. And finally, we get down to a point where we don't have any more x's except for the sine 3x. So this is going to be sine of 3x divided by 3 dx. And I'm going to say plus C2 since I took a second integration, right? Now, last thing I'm going to do is I'm going to take the antiderivative of this sine 3x, which is going to be a negative cosine 3x over 3, but we already have a 3. And then I'm also going to distribute the 10 thirds. In fact, I'll wait till the end to do that. All right, so next line is going to be negative 5 thirds x squared cos 3x plus 10 thirds. We're going to keep that x sine 3x over 3. We have a negative and then times a negative. So this is going to turn into a positive, and that comes from the antiderivative. We're going to have a cos of 3x, and we're going to have another 1/3. Okay, so I'm just going to say that's going to be 3 times 3, all right? Because remember, when we take the antiderivative, we have to divide it by another 3. All right, and I'm just going to call it plus C3 since I did a third integration, although it doesn't really matter at this point. You can call it C. Final answer, I'm going to distribute the 10 thirds through. And finally, what we end up with is going to be negative 5 thirds x squared cos 3x plus 10x sine 3x over 9, 3 times 3, and then finally plus 10 cos 3x divided by 9, or sorry, by 27, because we have another 3 outside. And then finally, I'm just going to call it C. All right, so although it looks like it's a pretty nasty problem, all right, it's not the easiest problem we could have done, but hopefully this helps you to understand the process of the integration by parts. All right, so our formula, UVV du. After that, it's just making sure your bookkeeping is going to be good while you're doing this.